You know, every single time you go online, you're basically stepping onto an invisible battlefield. There's this constant, silent war being waged for what's become one of your most valuable assets, your data. So let's dive into this battle and see what's really going on under the hood.
I mean, really think about that for a second. Is it? From your bank details to your private DMs, just how secure is all that stuff you're sending back and forth? So, in this explainer, we're going to map out that battlefield. We'll check out the armor that's available, and we'll even uncover some of the secret weapons used to protect your digital life.
All right, first things first, you've got to understand the enemy. In the world of network security, the threats aren't just some generic, faceless hackers and hoodies. It's more useful to think of them as two very different types of operatives. You've got your spies, and you've got your saboteurs.
So this is basically the battlefield map. What's so great about this is that it breaks down pretty much every cyber attack you can think of into just two big families. On one side, you have the passive attacks. Those are our spies. And on the other side, you have the active attacks. Those are the saboteurs. Let's take a closer look at what that actually means.
Okay, so the key difference here, it's all about intent. The passive attackers, they are all about stealth. They just want to be a fly on the wall. Listen in, maybe read your messages, figure out who you're talking to, all without you ever knowing they were there. Active attackers, though, are the complete opposite. They're loud. They want to cause a scene. They want to change things, break things, maybe shut down a whole website. They're there to do damage.
Speaking of causing chaos, let's zoom in on one of the most famous sabotage attacks out there, one I guarantee you've heard of, the denial of service attack, or DOS for short. It's a total classic, kind of the sledgehammer of the digital world.
The best way to think about it is like this. Imagine 1,000 people call your favorite pizza place at the exact same time, but none of them actually want to order a pizza. The phone lines just get completely jammed, right? No real customers can get their orders in. Well, a DOS attack is exactly that, but for a website or a network. It just floods the target with so much junk traffic that it gets overwhelmed and just crashes.
And these attacks, they come in all shapes and sizes. You've got your straightforward flooding attacks, but then you have these really clever amplification attacks that trick other systems into doing the heavy lifting. Some even use a specific bug in a system to crash it. But the biggest and baddest of them all is the DDoS, the distributed denial of service. That's when the attack comes not from one computer, but from thousands, even millions of hijacked computers all at once. An absolute nightmare to deal with.
And this right here is a perfect illustration of how one of the most common types works. See, normally, when your computer connects to a server, they do a quick 3-step handshake. Hello? Hi, I'm here. Great, let's talk. But in a SYN flood, the attacker just screams, hello, over and over again from thousands of different places and never finishes the handshake. The poor server is left holding the line for all these fake hellos, and it eventually runs out of memory, so real users can't get through.
So that's the scary stuff. You've got spies and saboteurs running around causing all sorts of digital chaos. How in the world do we fight back against that? Well, you build armor. Let's take a look at our first line of defense.
But you can't just start building armor without a plan, right? You need a blueprint. You have to start by asking the most fundamental question, what are we actually trying to protect? And in network security, that means defining a set of really clear goals, which are often called security services.
These right here are the 5 pillars of our digital fortress. First, authentication, proving you are who you claim to be. Then, access control. That's deciding who gets the keys to which doors. Data confidentiality is pretty straightforward. It's about keeping secret. Data integrity makes sure that nothing has been tampered with. And finally, this fancy-sounding one, non-repudiation. That's just a secure way of saying you can't deny that you sent a message. It's undeniable proof.
Okay, so those are the goals. That's the what. Now, we need to talk about the how. How do we actually pull all of this off? Well, for that, you need the right tools for the job, the specific technologies that make up our digital armor.
And here they are, the core tools in our security toolbox. We've got encryption, which scrambles data so it's unreadable to prying eyes. Digital signatures, which act like unforgeable, tamper-proof seals. And of course, firewalls, which are like the bouncers at the door, deciding what traffic gets in and out. These mechanisms are the real-world tech we use to achieve those big security goals.
Now I want to zoom in on one of these tools because it is just so clever. It's one of the most powerful and, frankly, one of the most elegant ideas in the entire security toolkit, the digital signature. It's basically a magic trick powered by math.
So what is it exactly? Well, first off, a digital signature is not a scanned picture of your handwriting. No.
It's a special block of cryptographic data that gives you 3 critical guarantees all at once: authentication, integrity, and non-repudiation. It proves who sent something, that it wasn't messed with, and that they can't deny sending it. It's a trifecta of security.
Okay, so let's walk through how this works. Let's say Alice wants to send a secure message to Bob. First, she creates a unique digital fingerprint of her message. This is called a hash or a digest. Then, and this is the most important part, she encrypts that fingerprint using her private key, a key that only she possesses. That encrypted fingerprint is the digital signature. She then attaches it to the original message and sends it off.
Now here comes the brilliant part. When Bob receives the message, he does 2 things at once. He takes Alice's public key, which is available to everyone, and uses it to decrypt her signature. That reveals the original fingerprint that Alice made. At the same time, he creates his own fingerprint from the message he received using the same method. And here's the moment of truth. If his fingerprint matches the one from Alice's signature, boom. He knows without a shadow of a doubt that the message came from Alice and that not a single character was changed along the way. It's so cool. This whole public key and private key system, it feels like magic, but it's not. It's just really, really clever math. It's powered by algorithms, and probably the most famous one is called RSA. It's what forges that special, unbreakable link between the 2 keys. Whoa, okay, I know this looks like a pop quiz from math class, but don't worry, you don't need to do the calculations. The core idea is what's so amazing. It all starts with 2 huge, secret prime numbers. You run them through a series of calculations, and out pop your public and private keys. Now, they're mathematically linked, but here's the genius of it. It's practically impossible to figure out the private key just from looking at the public one. It's like a mathematical one-way street. Here's the best way to think about it. Your public key is like an open padlock that you give out to everybody. Anyone can use it to snap a box shut for you. But once it's locked, the only thing in the entire universe that can open that box is your one-of-a-kind private key. One key locks, the other one unlocks. That beautifully simple relationship is what makes this whole system so incredibly secure.
So we've seen the threats, and we've seen the incredible technology designed to stop them. But even the strongest, most high-tech armor has a potential weak point. And that weak point, well, it's us. It's the human element.
See, all this amazing technology is totally useless without a good plan. And that's where security policies come in. You have your high-level ones, that's the why. The big picture mission statement, like we must protect all customer data. But then you need the low-level policies, that's the how. The specific, nitty-gritty rules, like your password has to be at least 12 characters long. You absolutely need both, the grand strategy and the on-the-ground tactics. And really, this brings us to the most crucial point of all. You can have the most advanced encryption, the strongest firewalls, the most brilliant digital signatures in the world, but if someone in your organization uses password123 or clicks on a sketchy email link, none of it matters. The whole system falls apart. So, at the end of the day, this digital battle isn't just fought by algorithms and servers in a data center somewhere. The technology gives us the armor, sure, but we're the people who have to actually wear it correctly. The battle is fought by each and every one of us, with every click we make and every password we choose. Which just leaves me with one final question for you to think about.